Okay, here is practice 6.1. Number 1, the probability distribution below is for the random variable x, which equals the number of mice caught in traps during a single night in small apartment building. Part A, make a histogram of this probability distribution in the grid. So they give us enough room for each bar to fit all of our x values, so 0, 1, 2, 3, 4, 5 along your horizontal axis, and then along your vertical axis we need to go from the lowest being 0.07 to the highest of 0.31. And so if we go by 0.05, we will be able to fit all of the data. So I'm going to start with 0.05, 0.10, 0.15, 0.20, 0.25, 0.30, and then 0.35. So 0 goes up to 0.12, 1 goes up to 0.20, 2 goes up to 0.31, 3 goes up to 0.14, 4 is at 0.16, and 5 is at 0.07. Okay, you'll notice on our grid that there's a bold bar at 0.20 and a bold bar at 0.35 on the copies. Just disregard that. There's nothing special about that. It's supposed to be just a regular grid, so it just kind of copied funny. Part B, describe the probability that x is greater than or equal to 2 in words and find its value. So in words, we need to remember what our x variable actually represents. It's the number of mice caught in traps during a single night. And so if we want x to be greater than or equal to 2, then that means that we want to catch 2 or more mice during a single night. Okay, so I'm going to write in words the probability because the P does stand for probability, that 2 or more mice are caught during a single night. And you could go on and be more specific and say in small apartment building and so on, but that's good enough. So that's in words, but now we need to also find the value. So the probability that x is greater than or equal to 2 is going to be the probability of 2 plus the probability of 3 plus the probability of 4 and then plus the probability of 5. So you want to add all of those up, 0.31 plus 0.14. Oh no, sorry about that. See if it'll let me come back. So 0.3, oh, come on now. Even with you guys not here with me, I still have all these technical difficulties. Let's go back to the pen. Can you get out of the way, please? Awesome. Okay, 0.31 plus 0.14 plus 0.16 plus 0.07. And so when I add all of those together, I do get 0.68. Okay, some of you are probably already thinking, well, it would have been easier just to subtract the ones you don't want. So remember that your entire probability does have to add to 1. So another way of doing it is you could do 1 minus the sum of 0's probability and 1's probability. So that would be 0.12 plus 0.20, so adding those together you get 0.32. Subtracting that from 1 still leaves you with the 0.68. So either way, correct answer there is 0.68. Okay, part C, express the event trapping at least one mouse in terms of x and find its probability. So they want us to go backwards this time. Instead of putting it in words, they want us to take the words and put it in symbol. So we want to say it's the probability that x, how do you say at least 1? At least 1 is going to be greater than or equal to 1. And so if you only strictly put strictly greater than, you didn't have the little bar underneath, it would actually be wrong because we need to include the 1 in there as well. And so if we want at least 1, then we basically just want everything except 0. So you can take it and you can add up the 1, the 2, the 3, the 4, and the 5. add all of those together, and it will give you 0.88, or you can do 1 minus the 0.12. And so that also gives you the 0.88. So final answer would be 0.88. Okay, number 2, the total sales on a randomly selected day at Joe's Toy Shop can be represented by the continuous random variable S, which has a normal distribution with a mean of $3,600 and a standard deviation of $500. Find and interpret the probability that S is greater than 4,000. So one of the big ideas that we're moving to in Chapter 6 is remembering back to our normal curve. That area underneath the curve, remember, it had to add to 1. And so with probability, that's a probability of 100. So believe it or not, the area under the curve still represents not only the proportion or the percentage underneath a certain z-score, but now it's also going to be the probability at that observed score. So we are going to go back to z-scores now. I know some of you are cringing. You thought you could forget about that, but no, we cannot. So we had the z-score formula was equal to observation minus mean over standard deviation. So they've actually given us everything we need to find, or that we need to know in order to find the z-score. So we have an observation at 4,000. We have a mean of 3,600, and then we have a standard deviation of 500. So we're going to say 4,000 minus 3,600, or 3,600, divided by 500, and that's going to give us our z-score. Okay, so when you work that out, you should get 0.8 for a z-score. Remember that when you have your normal curve, your z-score of 0 is right in the middle. And then it goes +1, +2, +3. So here's 1. So we're looking at a z-score of 0.8. Not sure why I made that a dotted line. Usually we do a solid line there. So we're looking at 0.8 for a z-score, and we need to figure out, do we need to go up the area above that or the area below it? So we have a probability of S greater than 4,000, so we want to go above that. We want to figure out what area is to the right of a z-score of 0.8. So on our calculator, we want to make sure we're going to positive infinity. Remember that we use 10 to represent positive infinity. So on my calculator, I'm going to go back and do the function that we haven't done in a very long time, which is the normal CDF. We're going to have a lower bound of 0.8. We're going to have an upper bound of 10 representing positive infinity. We're going to leave the mean at 0 and the standard deviation at 1. So we go second vars, it's number 2 for normal CDF. Again, our lower is 0.8, our upper is 10, and we want to leave the mean and the standard deviation at 0 and 1. Okay, when we run that, it tells us that that area right there is 0.2119. So we could say that about 21% of the data is above 4,000. Okay, to interpret it in the context of this problem, I really didn't leave enough room for that. So I am going to erase my work for the z-score. Hope you have that. If not, you might want to pause this really quick because it's going away. Okay, so with interpretations, they want us to actually write out a sentence and use the words that are in the context of our problem. So I say, there is a probability of 21% that the total sales on a randomly selected day you could go on and say at Joe's Toy Shop or whatever, will be greater than $4,000. Excuse me. Okay, on to the back. Number 3, Joe the barber charges $32 for a shave and haircut and $20 for just a haircut. So if you're going to get both, you're paying $32. If you're getting just a haircut, you're paying $20. Based on experience, he determines that the probability that a randomly selected customer comes in for a shave and haircut is 0.85. The rest of his customers come in for just a haircut. So let J equal what Joe charges a randomly selected customer. Part A, give the probability distribution for J. So J, let's go back and see what J is. J is what Joe charges. He either is going to charge you $20 or he's going to charge you $32, and that's it, okay? The probability that he's going to charge you $20 would be 0.15, since the probability that he's going to charge you $32 is given as 0.85. So 85% of the time, he's going to charge you $32 because you're getting a shave and a haircut. So that leaves us with 15% of the time he's going to charge you $20 because you're getting only a haircut. Okay, then it says find and interpret the mean of J, which we're going to call mu J. I'm going to scroll that up a little bit. Okay, so the mean amount of money Joe can expect to make would be the mu J. So this is the mean, the average, the mean amount of money Joe can expect to make. Let me say expect to make or expect to charge, however you want to word that is fine. So the way we're going to figure that out is, remember, 15% of the time he's going to charge you $20. So 0.15 times your $20, or, remember, or, so that 15% times $20 is you're getting just a haircut. Or 85% of the time, he's going to charge you $32, because those are the people that are going to get the haircut and the shave. So you're going to calculate that, and you end up with $30.20. Okay, so on average, he's going to charge $30.20. He can expect to make, on average, $30.20. Okay, part C, find and interpret the standard deviation of J, which we're going to use symbols of sigma J, or variable sigma J. So I'm going to scroll that up again. Okay, this is like the average distance. The answer sheet or the answer key uses the typical distance instead of average, but it's the typical distance that each customer would be away, or each data point would be away from the mean. So they say the typical distance from the mean, which is the $30.20 that you found previously, for each individual customer. Okay, so the not so fun way of doing it is to actually work it out. So we're going to find the variance first. The variance would be 0.15 times 20 minus 30.20 squared plus 0.85. I don't want a parenthesis there, so I'm going to erase that and rewrite that. 0.85 times 32 minus 30.20 squared. That would give us the variance, and then if you take the square root of that, you get back your standard deviation. So where the heck did I get these numbers from? This is the probability that you're going to have to pay $20. This is that $20, but then this is minus the mean. Okay, this is the probability that you're going to have to pay the $32, and so then you have your $32 again minus the mean. So you can work that out, and you'll get $4.28 approximately. Okay, or you can use your calculator, believe it or not. Okay, so let me walk you through that. We actually could have done the calculator on part B as well, instead of calculating and setting that up. So let me show you how to do that. Since we only have 2 data points, it's not all that, helpful or all that time saving. But if you had several data points, I personally would not want to waste my time doing some long, square roots and, chancing getting the numbers in the right spot or the wrong spot or whatever. So I would just be really careful of that. And so if you have more than just a couple of data points, I would go ahead and use the calculator as I'm about to demonstrate. So I'm going to go to Stat, Edit. I've already cleared my RAM, so I have nothing in there. And so in list 1, I want to put the J values, so $20 and $32. In list 2, I want to put the frequency, which is the probability of that happening. So I'm going to put 0.15 and I'm going to put 0.85. Hopefully you understand why I'm calling that frequency. It's because 15% of the time you're going to charge $20, and then 85% of the time, you're going to charge $32. So those really are frequencies of how much those amounts are going to be charged. We go to Stat, we go over to Calc. We want to do our one variable stats because that's what gives us the mean and the standard deviation. I do have the data in list 1. I've put the frequency in list 2. So I do want to go ahead and say that list 2 is there. If you just run it with list 1, it's not going to run correctly. So you do have to put the frequency in list 2, and you want to calculate that. Notice that our average is 30.2, which is our $30.20, and then we have a standard deviation of 4.28 when you round it from our calculator. Okay, so the calculator is really helpful to save us the time of having to actually work that square root formula out. Okay.